This question is an important question, students. Here there is a determinant in terms of r which is given. Is it okay? And if you look at this part, summation is applied from r is equal to 1 to n. So when summation is applied from r is equal to 1 to n, basically there will be how many values now? N values only. If summation was applied from 0 to n, then there will be n plus 1 value. Starting from 1, if we count 5, 1, 2, 3, 4, 5, only 5 values. So starting from 1 to n, if you count summation, then there will be n values. Alright. Now we'll try to apply the summation. Sigma r is equal to 1 to n of delta r will be equal to, you can summate this entire column or you have to summate the entire row. In row n is there, it is free from r, so I can treat this 1 can be treated as r power 0. You have to summate any one row or you have to summate the column. That's the meaning of it. You cannot leave this 1 as it is. So sigma r is equal to 1 to n of 1, then 2 into sigma r is equal to 1 to n of r, and sigma r is equal to 1 to n. I'll write here like this only, 2r. Is it okay? 2r, and this part will be equal to 2r minus 1, and n square plus n plus 1, and then n square n square plus n and n square plus n plus 1, and this value after summation is given in the problem as 56. Now question is asking you what is the value of n. Now we know that sigma r is equal to 1 to n of 1. This value will be equal to how much? 1 will go on getting added n times. So answer is n. Similarly, sigma r is equal to 1 to n of 2r can be written as 2 times sigma r is equal to 1 to n of r. From the special series expansion, we know that this is 2 into r plus 1 divided by 2. So which can be written as, but r value is taking n, right? 2 and 2 will get cancelled. N into n plus 1. Is right? N into n plus 1. And similarly, sigma r is equal to 1 to n, 2r minus 1 can be written as n into n plus 1, that is for this part which we have already calculated, minus of n. So n square plus n minus n, that is equal to n square. Are you getting it? That is equal to n square. So this part will be equal to n, and this is n square plus n, and this is n square. Are you getting it? N square. N square, and then this is n, this is n, n square plus n plus 1, n square plus n, n square plus n plus 1. Correct or not? Now, C1 forms C1 minus, or C2 forms C2 minus C1 transformation. C3 transforms to C3 minus C1 transformation. 56, that is equal to n 0 0 transformation here. Then this part will remain untransformed, n square plus n. Here this will be 1 and this part will become equal to 0. And here this is n square, this is 0, and this is n plus 1. Is it right? So 56, that is equal to, if we expand, n into n plus 1 minus 0 into anything plus 0 into anything. So your answer will be 56 is equal to n square plus n. So we come up to a quadratic equation form, students. N square plus n minus 56 is equal to 0. So I can say, so what is the sum and product if you split? Plus 8n and minus 7n is minus 56 is equal to 0. Upon solving, you will get n is equal to minus 8 and n is equal to 7. So answer number here, whenever we are taking summation here, as far as this number is concerned, we are adding the values, right? Look at the option. Option available is n is equal to 7. One option is there. That is the answer.